We're solving problem 6 from the 2020 F equals MA exam A. A planet is orbiting a star in a circular orbit of radius r0. Over a very long period of time, much greater than the period of the orbit, the star slowly and steadily loses 1% of its mass. Throughout the process, the planet's orbit remains approximately circular. We want to calculate the final orbit's radius is closest to, and then it gives us a set of values. So for this case, we can set an equation. We know that L is equal to mvr. And for circular orbits, we can call this the star capital M and the planet little m, and the circle shows the orbit. So then this would be, what would it be? This is gm over r squared equals v squared over r. This is for circular orbits where you equate like two masses together. And then these cancel. To solve for v, you get that v is equal to square root gm over r. It is then true that L is proportional to the big mass of the star times r, the radius. And then the mass is proportional to the inverse of r. Therefore, we have this, right? You can then say that r0 over r final is equal to m0 over m final, which is 0.99. Now, it would seem evident that our answer is 0.99 r0, but we have to think a little bit. If the star decreases its mass and the planet is orbiting around it, then the gravitational field would weaken, so that would cause the planet to go a little further out. Therefore, we know it's not 0.99. So we can rewrite this as r final is 1.01 r0, where this is the right answer because the radius is further out.